quick. What does this print? We're adding three trues together, not comparing anything, not checking a condition, just true plus true plus true. Take an actual guess in your head before I hit run, because the answer tells you something surprising about Python. 3. Not an error, not the word true, the number 3. It turns out Python's true and false are secretly numbers wearing a costume. And once you understand that, a whole pile of everyday code suddenly gets shorter and cleaner. So let's build up to it properly from the very bottom. This is Booleans, the type with exactly two values, true and false. It's the smallest type in the whole language, and it's also the most important, because every decision your program will ever make comes down to one of these two values. Here's the plan. First, what a Boolean actually is, then how comparisons create them out of thin air, then how to flip and combine them, and finally, that integer secret from the cold open, plus a couple of real-world ways you'll use all of this. Start with the idea itself. Picture a light switch. It's either on or off, true or false, no third position, no halfway. That's a Boolean. Any fact you can answer with a plain yes or no is one of these switches. Is the user logged in? Is the card empty? Each one is a single switch. Let's put them into real code and see how they behave. We store true in a variable. Notice the capital T. That's not a style choice. Python genuinely insists on it, and I'll show you what happens if you forget in a second. And false, capital F, in another variable. See how these names read like little questions. He is on is raining. That's the habit to build. A good Boolean name should sound like something you can answer yes or no. True and false, printed straight back at us. Nothing fancy yet. But watch what happens the instant you get that capital letter wrong. Because you will. Everyone does once. Here's the mistake almost every beginner makes on day one. Lowercase true. It looks completely reasonable. Predict what Python does with it before I run it. A name error. Python read lowercase true as the name of some variable, went looking for it, found nothing, and stopped. The fix is just that one capital letter. In Python, the two Boolean values are always written true and false. Big first letter every single time. Lowercase true and false simply don't exist here. So where do these values actually come from in practice? Here's the thing. You almost never type true by hand. Instead, you ask Python a question, like, is 7 greater than 3? And Python computes the answer and hands you back a Boolean. The comparison is the question. The Boolean is the answer. These are the comparison operators, and each one is just a yes or no question. Greater than. Is 7 bigger than 3? It is, so Python gives back true. Now the big one. Double equals asks, are these two things equal? 1 equals sign assigns a value. 2 equals signs compare. 7 is not 3, so this comes back false. Exclamation mark equals means not equal. 7 really isn't 3, so this flips the other way. True. And less than or equal. 3 isn't less than 3, but it is equal to it, and that counts, so this is true as well. Is 7 greater than 3? Yes. So this line produces true right here. Is 7 equal to 3? No. So this comparison hands back false. 7 really isn't 3, so the not equal check flips to true. And 3 is equal to 3, which counts. So this one is true as well, and Python has a lovely shortcut. Most languages don't. Say age is 12 and ask 2 range questions. You can chain comparisons the way you would in math. This reads, is age between 3 and 18. And Python understands it exactly like that. So you can sanity check a value with a single, readable line. Is this age somewhere between 0 and 120? No repeating the variable, no extra words. Is 12 between 3 and 18? Yes. This line gives true. And is it between 0 and 120? Also yes. True again. Now back to that trap I flagged. It's worth slowing down on. 1 equals sign assigns. It takes a value and puts it into a variable. 2 equals signs compare. They ask whether two things are the same and give you back a Boolean. They look almost identical and they do completely different jobs. Mixing them up is the single most common beginner bug there is. So, whenever you mean, is this equal to that? Reach for 2 equals, always. Sometimes you don't want the answer. You want its opposite. The keyword not takes a Boolean and flips it. Not true becomes false. Not false becomes true. Think of it as a switch flipper. One little word that reverses whatever answer you hand it. That's all it does, but it makes code read beautifully. Here's not doing real work in a login check. We start logged out. Logged in is false. Not logged in flips that false into true, so this line prints true. And here's why it matters. Read this out loud. If not logged in, please log in. The code says exactly what it means. That readability is the whole reason not exists. True. And then the prompt to log in. When your conditions read like plain English sentences, you catch your own bugs faster, and so does anyone reading your code later. That's a habit worth forming now. By the way, not is one of 3 logic words. The other 2, and or, let you combine several Booleans into one answer. Those get a full episode of their own soon. All right, time to pay off that opening surprise. Under the hood, true is literally the number 1, and false is literally the number 0. So when you write true plus true, Python isn't doing anything magical. It's just adding 1 plus 1 and handing you 2. And this isn't a quirky accident. Booleans were built directly on top of integers, so they carry those number values everywhere they go. This isn't a party trick. You'll reach for it constantly. True is genuinely equal to 1. Python confirms it right there. And false is equal to 0, which unlocks a genuinely useful trick. Imagine these are 5 yes or no votes. Call sum on the list, and Python adds up the 1s and the 0s, which means it counts the trues for you in a single line with no loop and no counter variable. True really is equal to 1, and here's Python confirming it, true. And false is equal to 0, which comes back true as well. Now sum adds the 1s and 0s in the list, counting the 3 trues, giving 3. Last piece, how everything else becomes a Boolean. The bool function takes any value and asks, is this truthy or falsy? Bool of 0 is false. 0 counts as empty, as nothing. But any other number is true. 42 is true. Even -1 is true. It's not about positive or negative, it's about being non-zero. An empty string, nothing at all between the quotes, is false. And a string with actual characters in it is true. Zero counts as empty, so bool of 0 produces false right here. But any non-zero number is truthy. 42 comes back true. An empty string, nothing between the quotes, is false. And a string with actual characters in it is true. Before we wrap, one habit that separates tidy code from messy code. Watch how naming your Booleans makes the whole program read like a description of itself. Instead of burying a comparison deep inside some later line, compute it once and give the result a clear name. Is age at least 18? Store that answer in as adult. Now adult is a Boolean you can print, reuse, and reason about. And the name tells anyone reading it exactly what it means. Same move again. Did they score at least 60? Store the yes or no in past. Notice the score is 55, so keep an eye on what this one comes back as. This print produced the first line. Old enough is true since 20 clears 18. And this one produced the second. Past is false because 55 fell short of 60. So let's tie it together. Booleans are the yes-no type, capital T, true, and capital F, false. No third option. You rarely type them directly. Comparisons produce them, not flips them, and deep down they're just 1 and 0, which is why you can sum them to count. And remember the two traps. Lowercase true throwing a name error, and 1 equals sign assigning when you meant 2. Get comfortable here because every decision your code ever makes is built on this one tiny type. Here's a 10-second challenge before you go. Make a list of 5 Booleans, mix true and false however you like, then use sum to count how many are true. Predict the number first, then run it and check. If you nailed the prediction, the integer secret is yours for good. Pause and give it a shot. Next up, we meet the one value in Python that means nothing at all. It's not 0. It's not false. It's not an empty string. It's none. And quietly misunderstanding it causes some of the most confusing bugs beginners ever hit. I'll show you exactly what none is, why it exists, and when to reach for it. See you in the next